Hello everyone, welcome back to RK Physics Shiksha. In today's video, we are going to discuss a numerical from Newton's laws of motion, where we have mass of 0.5 kilogram, a ball of mass 0.5 kilogram, which has been dropped from a height of 40 meter, and the ball hits the ground, rises back to a height of 10 meters. The impulse imparted to the ball during its collision with the ground is given that g is to be taken as 9.8 meter per second square. Let us understand this concept behind the question, which is very simple. That we have to calculate the impulse, where impulse is represented with J is equal to force into time, where J can also be written as change in momentum by time, or you just can write it the other way around like this, where impulse J is equal to force into time delta t, and J is equal to force is written as change in momentum by time into delta t, where we have time gets cancelled out and we can write the impulse as J is equal to change in its momentum. So change in its momentum, in the sense we can write it as J is equal to the same particle will have the change in momentum. So mass into final velocity minus mass into initial velocity. That gives me impulse J is equal to mass taken common out. We'll get final velocity minus the initial velocity. This is the relation that we have for the impulse concept. So we have the mass. Yes, we have the mass, and we have the heights through which height to which it is falling, and height to which it is rising back again to. So using this data, let us calculate the final and the initial velocities, meaning the velocity with which it will hit the ground is the initial v initial, and the velocity with which it will bounce back from the ground after hitting is the velocity vf, if we consider. In that case, for v initial to calculate, we have to calculate v initial here. So I use v square minus u square is equal to 2as. This is the equation of motion, where you have an object that is falling from a height h, or h1 in this case, the height h1, which is equal to 40 meters. And for a body which is under free fall, we have initial velocity is equal to 0, and its final velocity v is equal to vi we have considered. So that is what we are supposed to calculate now. And here g is acceleration due to gravity, and it is directed along the direction of the motion to be taken positive. So putting all these values in the equation, I'll get vi square minus 0 is equal to 2 into g into h1, from which vi square is equal to 2 into 9.8 into 40. So what will be the value of initial value of square is equal to, we get it as, let us check for the calculator. Yes, we have it, and just dropped it here. Yes, 2 into 9.8 into 40 will give you how much? 40 into 9.784, and root of 784 will be the answer for the initial, which is 28. So that gives me here root of 7, sorry, not root, I get it as 784, and vi is equal to root of 784, that will be equal to 28 meter per second. Now after hitting the ground, the ball will rebounds back, and let us assume that the speed with which it will rebounds back is vf, and so we are supposed to calculate the vf now. Vf is equal to be calculated. For that also we use equation of motion, which is v square minus u square is equal to 2as. And here consideration is that the body is here on the ground, after hitting the ground, it will bounce back to a height which is h2, which is equal to 10 meters. And now after hitting, it'll go to a height 10 meters, and then it'll have its final velocity is equal to 0. It'll reach only the maximum height of 10 meters, means its final velocity v is equal to 0, and its initial velocity is equal to vf. That is what we have considered. So it will bounce back with vf velocity. Now to calculate this vf, let us substitute. And also one more thing that we have to remember is a is equal to here minus g, because it is directed opposite, always downward. So we have to take it minus g. It is opposite to the direction of the motion. So we take it minus g. And what we get now here is very simply substituting all the values. I get 0 minus u square, which is vf square, is equal to minus 2g h2, and minus here minus vf square is equal to minus 2gh2, where we can cancel this negative sign out here. And what we get here is vf is equal to root of 2 into 9.8 into 10, which is 98 into 2. We have it as 9.8 into 10 into 2. That gives me 196. And root of 196 will be equal to 14. So that will be vf is equal to, we have it as root of 196, from which I get it as 14 meter per second. This is the velocity vf. Now we have the relation for the calculation of impulse, and that impulse is j is equal to, this is the actual thing what we are supposed to calculate now. J is equal to, the mass is 0.5, which we can write it as 1 by 2, into change in momentum is final momentum minus the initial momentum. Sorry, final velocity, mass into final velocity minus the initial velocity. The final velocity, that is the velocity with which it will bounce back, is 14 minus of the initial velocity, which is they are directed opposite. So one is to be taken positive, the other is to be taken negative. So minus 28 will give me j is equal to 1 by 2 times of, I'll get it as 42. 28 plus 14 will give me 42, and simplifying this, I'll get it as 21, and that will be the impulse, which is equal to 21 Newton second. This is the answer. The impulse that is there imparted on the ball is 21 Newton second. So in the provided options, the correct option would be the third option, which is 21 Newton second, which is C. Hope you understood. For more such videos, please do like, share, comment, and subscribe our channel. Thank you.